Welcome to CS 1401 Video 10.1, in which I'll talk about arrays. In computer science, systematic ways to organize information are called data structures. The array is a common and very useful data structure, and in this video I'll describe the concept of arrays and their implementation in Java. Let's say I want to create a grocery list, or I'd like to buy zucchini, salmon, napkins, pico de gallo, and brown rice. It would be inconvenient to have to create a new variable for each item. I would have to create a variable item 1 and assign it the value zucchini, create a variable item 2 and assign it the value salmon, and so on. If I wanted to do anything with my grocery list, I'd have to deal with all 5 variables, and if I had a really long list, maybe I'm planning a party, I'd have to deal with a lot of variables. It would be a lot easier if I could refer to the entire collection of values with a single variable, and that's what an array provides. The array is, in essence, a sort of table to which I can refer as a single variable and still access the individual entries in the table. In an array, each entry consists of an index and a value. The index is an integer, and the value can be anything. Here, for example, is an array that represents my grocery list. The first element in the array has index 0, and its value is zucchini. The second element in the array has index 1, and its value is salmon, and so forth. In this example, there really isn't any order to the items in the array, but putting them in an array data structure makes it possible to refer to the entire list instead of having to create a whole slew of variables. We've actually already seen the idea of an array when we looked at computer memory. You'll recall that each location in memory has an address and, possibly, some contents. So memory is like an array where the address is the index and the content is the value. The fact that the indexes of an array are ordered integers can be helpful. For example, we might have a list of top 10 national research universities as ranked by the Washington Monthly for 2014. Number 1, the top university, is UC San Diego, and that's in array element with index 0. The next highest in array element with index 1 is UC Riverside, then UC Berkeley. In array element 3 is Texas A&M. The array element with index 4 is UCLA, then Stanford, then the University of Washington. Then UTEP is in array element with index 7, and then followed by Case Western Reserve, and Harvard rounds out the top 10. Here, the order matters. The University of Washington is ranked higher than UTEP, and UTEP is ranked higher than Case Western Reserve University. An array enables us to access each element of the array directly. So if my array is called top universities, I can get the very top university by accessing element 0 of top universities. In pseudocode, this might read top universities sub 0. And I can get the 7th element too as top universities sub 7. This enables me to write statements such as assign the value of top universities sub 7 to the variable myChoice, which would assign the string UTEP to the variable myChoice. Here's another example. Let's say that a store has a lot of shipments that need to be sent. Each shipment has a unique tracking number, and someone has figured out the order in which the shipments should be sent. To enable everyone to know which shipment to work on next, we can create an array that lists the tracking numbers in the order in which they should be processed. So the tracking number in array element with index 0 indicates the order that should be shipped first. The tracking number in the array element with index 1 indicates the shipment that should be processed next, and so forth. This enables us to radically simplify one of the algorithms we've seen before, giving the name of the month that corresponds to the number of the month. In the video on conditionals, I presented an algorithm that had a dozen if-elses. By using an array, I can make the algorithm much, much simpler. My algorithm is called monthName, and it takes a single argument, which is the number of the month, like the number of the month of January is 1, and so forth. The first thing I will do is initialize an array with the names of the months as strings. My variable will be called the months, and putting the two brackets, square brackets, after the name of the variable indicates it's going to be an array, and I'll assign that new variable, the array the months, the values in the brackets. Then the rest of the program is pretty simple. If the month number is less than 1 and the month number is greater than 12, well, then I've got an invalid month, and I'm not going to be able to print out the name of the month, so I'll print out invalid month. Otherwise, I know I've got a number that's between 1 and 12, so I'll print out the month name. Now, let's think about this just for a second. The months go from 1 to 12, but my array indices will go from 0 to 11. So if I want the name of the month that corresponds with the number of a month, I'll have to subtract 1 from it. In other words, if the month coming in is 1, I need the name January to come out, which is in array element 0. So I'll subtract 1 from 1 and get 0 and print month name sub 0. Similarly, if the number coming is 9, and I want to print out September, well then I'll subtract 1 from 9, giving 8, and I'll print out what's in the array in index 8, which is the string September. With this approach, I can do something even more useful. I can also indicate how many days are in the named month. Here's my new algorithm. It starts out just the same, except now I'm going to call my algorithm month name and length. I'll initialize my array of names called the months, and then I will also initialize another array called month length, and that will have 12 elements, and each element will be the number of days in the corresponding month. So January has 31 days, so the first element of month length is 31. February has 28 days, well, except in leap years. And so the element with array index 1 will be 28, and so forth. The rest of the algorithm is pretty much the same. First, I'll check to make sure I've got a valid month, and if I don't, I'll print an invalid month. Otherwise, I'll decrement the month number by 1, just like we did in the prior algorithm, and then I'll print out the month name has whatever number of days there are, days. One nice thing is that we've already used arrays in Java, even if we didn't know it. Remember how we accessed arguments to a method? For example, here's how we accessed the 5 cards for our program highest card. We can see now that each of the arguments from arg sub 0 to arg sub 4 was an element in an array of strings. So we're already experienced in getting values from an array. With this experience in mind, here's the implementation of month name and length. I'll initialize 2 arrays, and each array will be of length 12. The first array will hold 12 strings representing the months of the year. The second array will hold 12 integers, where each array element represents the length of the corresponding month. So array element 0 is 31, which means that January has 31 days. Array element 1 is 28, which means that February has 28 days, and so forth. The program gets one argument from the command line, which will be assigned to month number, and that's the number of the month whose name and length we're trying to find. First, we'll check to see if the month number is valid. So it has to be between 1 and 12 inclusive to represent a valid month. So if it's less than 1 or greater than 12, I'll print out invalid month, and that's the last thing we'll do. Else, I'll subtract 1 from the month number so that the number of the month will correspond to its position in the array, and then I'll print out the name of the month, has, and then the number of days in that month from its corresponding position in the month length array. Next, I'll try out my Java program, and I'm going to test it by using values around the boundaries of the test cases in the program. Remember that the program first checks to see that the argument coming in is a number between 1 and 12. So I can check to see if my value coming in is just outside that boundary, that would be 0, or just above the boundary, that would be 13, and then just within the boundary, that's 1, or just within the boundary on the top, that's 12. And then we'll try a value in the middle. So I compile my program, and I'll run it with 0, then with 13, then with 1, then with 12, and then with 6. And in all cases, the output's exactly as we expected. So that's an introduction to arrays, both in pseudocode and implemented in Java. In the next video, I'll talk about how to combine arrays with iteration. See you then.